Hey friends, we are not working at FAANG yet, so let's not stop lead coding. Today we are going to solve question number 217, contains duplicate. This is a very easy and simple problem to understand. We are given an array of integers and we need to check that whether that particular array contains any duplicate numbers. If it does contain duplicate numbers, we need to return true, and if all the numbers are distinct, we return false. Let's see it in an example below, which it makes more sense. Over here in the first example, we can see that value 1 is repeated twice in the given input array. So we can basically say that yes, it does contain duplicate, and we are going to return true for that. If we look at the second example, we see that all four elements are distinct and we don't see any repeated element. So we return false and we said that there are no duplicate entries in the given array. What would be the brute force approach in this case is going to be? Let's see it with an example. We are given an array of following values 5, 8, 13, 9, and 8. And over here, by the looks of it, we can see that that does contain duplicate values. A brute force approach would be by checking every single value with all the values remaining in an array to make sure that whether the same value is being repeated or not. In this approach, we will take the first value 5 and we will compare it with all the remaining values in the given array. So we will first of all we'll check between 5 and 8 and we see that whether are they same. If they are not same, we move on to the next one. We check that whether 5 and 13 are same. Again, they are not same. We move on to next. We check for 5 and 9. Again, they are not same. We move on to next. And 5 and 8. Again, we don't find anything, which basically concludes that there are no entries in the given array with value 5 that are being repeated. Now let's check with the for the second element in the given array. And if we check with value number 8, we can see that 8 to 13 there is no matching pair. 8 to 9 again there is no matching pair. And we come to the last value, we can see that 8 is being repeated and we can basically conclude that this given input array, we can simply return the true in this case and we would be done. So brute force solution would work perfectly fine, but what are the issues with the brute force approach? We can see over here that for every single element, we are basically comparing it to all the other elements, and then we are going to keep on doing it repeat for the entire remainder of array, which is really bad. And that basically provides us with time complexity of big O of n square, which is a really bad time complexity. And in terms of space complexity, we are not using much space, so we are using a big O of 1 space complexity. Now let's see that can we do a better approach? And yes, we can have a better approach. So first better approach is I'm going to show you that, say for an example, we are given an input array and somehow for this given input array, if we sort the array, can we find a better input that would make our lives easier? And the answer is yes. We would find an input something like this: 5, 8, 8, 9, and 11. We just need to traverse array once from starting to end, and we only need to compare two elements at a time which are next to each other. And in any scenario, if we find that the two elements adjacent to each other are same, then we can conclude that the given array contains duplicate. Now, this approach is definitely better than our brute force approach. And So what would be the time complexity for this one? The time complexity for this approach would be big O of n log n, and we are coming up with this time complexity is because we need to sort the value first for the input array, and sorting is going to cost n log n. So that's why this would be our final time complexity, and space complexity would be we might need to store additional space to storing the array. So we need to have big O of n space complexity. Now this and space complexity is definitely better time complexity than our brute force approach, which was big O of n square and which was really bad. And space complexity, yes, we have some issues over here compared to our brute force approach. But in my experience, typically space complexity comes in less precedence than time complexity, and we need to focus more on this one. So let's see that can we have another approach where we can have better time complexity than big O of n log n? And the answer is yes. We do to gain that better time complexity, we need to use a new data structure. In this case, what we are going to do is we are going to create a hash set, and every time we traverse through the given array for the given values, we would keep checking that whether that value exists in the hash set or not. And if it does not exist in the hash set, we will add that particular value. So let's take it from example, and our values are 5, 8, 11, 9, and 8, and see that what could be our scenario and how can we check that. So first of all, this is our hash set and this is our input array. And so first of all, we would start that whether 5 exists in the given hash set, and we can see that there are no entries currently in the hash set. So we will simply add 5 to the hash set and we would move on to the next value. We would check that whether 8 exists in the hash set. We see that 8 does not exist, so we would add 8 and move on to the next value. Again 11, same thing. And same goes for 9, that 9 does not exist on the given hash set. But when we come to 8, we can simply say that 8 does exist in the given hash set, and we know this, and because 8 is already present, and also on the hash set, searching operation is big O of one time. So this gives us the results really fast by just looking it into the hash set, and we can return that for this given scenario. It does contain duplicate, so we can return, I'm messing up my spelling of true. Okay, let me do it again. So we can return true for the given input array, and this would be our solution. And if we reach to the end of the array and we say, for example, we don't have this given here and we only have 4 elements in the given input array, we can simply return false for this case because we reached the end of the array and we did not find any duplicate entries. So I think the solution makes sense. And if we were to calculate the big O of time and space complexity, the time complexity for this one would be big O of n, which is really good. This is the best time complexity out of all three solutions we found. And the space complexity would be big O of n as well because we need to use an additional hash set. But in a single traversal towards the array, we would be able to find the result, which would be the most optimal scenario. Now let's move on to coding. Okay, let's work on the coding solution. And as mentioned that we are going to use a new data structure hash set for this problem. So let's create a hash set that works with integer values and just name it as set, or we can name anything. Now we are going to create a for loop that is going to iterate over the input array. Now we are simply going to check that whether the given value is in set or not. So if set contains nums of I, we can simply return true, else we add the value to the set. And if we reach the end of the loop, we simply return false. Let's try to run the code. Oh, Looks like we missed the semicolon. Yeah, it works. Let's try to submit it. And we can see our solution works pretty fast, and it is faster than a lot of other submissions online. This was a really simple and easy problem, but it gives us an idea that how can we use multiple data structures that are available to us, and we can use it to gain optimal solution. Thank you.